Hello students, this is PVR. Today I am going to teach you motion in straight line, a lesson from first year. So before going to learn about that, we have to learn a certain fundamental definitions as well as some physical quantities. Okay, let us discuss about them. In our physics, throughout the all lessons, we might heard about one physical quantity like a scalar. What is meant by the scalar? Scalar is a physical quantity which is having only magnitude but no direction. That is called as the scalar physical quantity. Here magnitude means what? Magnitude is nothing but a numerical value. Okay. For example, if I am taking the distance between the Amalapuram and Ravulapalam, if it is taken 20 kilometers or 30 kilometers, whatever it may be the distance. Suppose if it is 20 kilometer, there 20 is the numerical value. So that gives us the magnitude. And the distance is a physical quantity. Distance is a physical quantity. Kilometer is the unit. Okay. Now here, scalar quantity means a physical quantity. A physical quantity which is having only magnitude but no direction. So in the definition itself I told you, having the magnitude is nothing but the numerical value, and no direction, it has no direction also. Okay, got it? Right. For example, if you are taking the distance is a scalar physical quantity. Okay, example, distance. The distance between the 2 points is 20 meter. So there 20 meter, 20 is the numerical value and it gives us the magnitude. Okay, meter is the unit. Next, it is having no direction. No direction means in order to reach from one place to the another place, there might be several type of ways will be there. Among all of them, only one path will have the straightforward or certain direction. The remaining all paths will not have the directions. For example, if you are taking the 2 points here, point A and point B. To reach from A to B, I am drawing the 3 paths. This is path 1 and this is path 2 and this is path 3. Okay. Among these 3, which one is having the shortest one? Path 2 is the shortest one and path 1 is somewhere far and path 3 is longer one. Okay, these path 1 and 3 will be they are not having the particular direction, whereas path 2 is straight forward to the B. Okay, straight forward to the B. This is having the particular direction. But here what we are told, what I told here, it should not have the direction. So here this path 1 and path 3 can be considered as those distances can be considered as the scalar physical quantities, because those are not having the directions, whereas they are having the magnitudes. For example, this one, if you are taking 19 kilometer and this might be 30 kilometer, 30 is the magnitude, and here 19 kilometer, 19 is the magnitude. Is it clear? Right. Next is vector. Vector also, it is a physical quantity which is having the magnitude as well as direction. So here it will have the magnitude plus direction. Basically we define the vector by using these two only. That means with respect to the magnitude and the direction only. Okay, in both of the vectors as well as the scalars, the common point is magnitude only. The common point is magnitude. Both are having the magnitudes, whereas the vectors additionally having the direction. Okay, along with this, some other definitions also there. If a physical quantity follows vector laws of addition, then it is a vector. It is a vector. That means, say, addition of numbers. If you are taking the addition of numbers, for example, 2 plus 3, it gives us the 5, and 3 plus 2 gives us the 5 only. That means even though changing the numbers, we are getting the same result, isn't it or not? In case of the vectors, what it will be? The vectors can be represented with the positive sign as well as the negative sign. Suppose while you are traveling from A to B through a path, then in the one direction that can be taken as positive, and in the opposite direction that can be taken as the negative. Suppose if the distance between these two is 20 meter, if AB is equals to 20 meter, then A to B can be taken as the plus 20 and B to A can be taken as the minus 20. So vectorially the values will be having the positive as well as the negative signs here. Positive as well as the negative signs here. Upon adding these two, what is the total displacement? What is the total distance between these two? If you are getting, then this will be 0. Okay, so total value will be. So here, upon adding these two, we are getting the 0. In case of the scalar quantities, no negative, no positive. Okay, sorry, no positive will be there, all are positive. Sorry, no negative will be there, all are positives only. That means whenever you are moving from A to B, that can be taken as the 20, and B to A also can be taken as the 20 according to the data. Then what you will have? So the total distance will be taken given by 20 plus 20 is equals to 40, whereas the displacement is vectorially. Suppose if you are taking vectorially, that can be 0. Got it or not? Okay, right. Next. Suppose weather telecast. If you have heard about the weather telecast, what it will be? Sometimes the telecast might be likewise during the cyclone time. The wind blows with a speed of 200 kmph. 200 kmph. In the eastward direction or westward direction or northeast direction, certain directions, along with the certain directions they will give us, isn't it or not? So here 200 is the magnitude, that gives us the magnitude, and eastward direction. Suppose if it is eastward or westward, whatever it may be the direction, this gives us the direction. Here kmph, kilometer per hour, kilometer per hour. So in this one, in 1 hour the wind blows with a speed of 200 kilometer. That means it covers a distance of 200 kilometer in 1 hour. So this is the unit. Is it clear? So a physical quantity which is having the both magnitude as well as the direction is called as the vector quantity, and sometimes it also can be defined as if it follows the vector laws of addition, that is also can be taken as the vector quantity. Okay, now let us see some physical quantities that you learned earlier in the lower classes. The first one is distance. Distance. What is meant by the distance? The path traced by the particle is called as the distance. Path traced by the particle means, suppose if you are taking the point B A and this is the point B. From A to B, we are having the different ways in order to reach B. This is one path and this is another path and this is another path. 1, 2 and 3. These 3 paths we are having here. Along which path or along which curve you are following in order to reach to the other point, that is called as the distance. Okay, so here among all these 3, the path 2 is shortest one. The path 2 is shortest one and the path 1 is somewhat greater than the path 2 and path 3 is longer one among all these 3. Now it is not having any particular direction in case of the path 1 and path 3, whereas in path 2 from A to B it is a straight path. If it is a straight path means it is having a particular direction. So if it is having the particular direction means that the distance will be taken as a vector quantity. That means it can be taken as a displacement. Okay, that we can define later. So what is the distance? Path traced by particle. Okay, right? Next is it a vector quantity or scalar quantity? Second one is the distance vector or scalar? It is a scalar quantity as it is not having the direction. Okay, so it is a scalar quantity. I already told you what is scalar quantity, which is having magnitude only but no direction. Next, units. How the distance can be measured? In meters or centimeters or kilometers? In all these units we can measure the distance covered by the particle. But we are having certain basic units. Those are CGS system units, FPS system units and MKS system units. What are they? CGS, FPS as well as MKS. 3 types of system of units are there. In this one, C refers to centimeter, G refers to gram and S refers to second. Next, F refers to foot and P refers to pound and S refers to second, M refers to meter, K refers to kilometer and S refers to second. In all these 3, second is common. That means the time can be measured in seconds only. Okay, apart from this we are having some other system that is called as the system of international units. In order to get the uniformity around the world in all countries, this system of international units can be introduced here. Okay, there is a similarity between the MKS as well as the SI units. What are the units for the separate different physical quantities? The same type of units also will be in SI. Maximum number of physical quantities will be coincide. That means units will be coincide. Okay. Now according to that, what is the SI unit or CGS unit? First SI unit. According to SI unit, the distance can be measured in terms of meter only or m. CGS unit. CGS unit is centimeter. CGS unit is centimeter. Next, dimensional formula. Dimensional formula. What is meant by the dimensional formula? Here let us see. There are fundamentally 7 fundamental physical quantities in our physics. They are, first one is mass. This is denoted with the letter, capital letter M. Next is length, denoted with the letter capital L. Next, time, denoted with the letter capital T. Next, strength of the current. Strength of the current. Denoted with I, R, A. Okay, and the next one is absolute temperature. Absolute temperature. This is denoted with theta. Next, intensity of light. Intensity of light. This is CD, candela. Next, amount of substance or matter. Amount of matter or substance. And this can be represented with mole. These 7 are 1, 2, 3, 4, 5, 6, 7. So these 7 are called as the fundamental physical quantities. Okay. By using these only, we will get the remaining all physical quantities in our physics. Right. So here mass means it can be represented with M. Next, length can be represented with L. Time T. Strength of the current I or capital A. Absolute temperature and ordinary temperature B. These are different scales. Degree Celsius, degree Fahrenheit. These are not. Absolute scale of temperature means Kelvin only. Absolute scale of temperature means Kelvin only we have to use. Okay. Next, intensity of light, candela, and amount of matter or substance that can be taken as mole. Now, by using all these 7 fundamental quantities, among all these, most frequently M, L, T, I, theta. These physical quantities frequently we can use. Okay. Now coming to the point, what is dimensional formula? Dimensional formula means it is an equation which represents the physical quantity in terms of the fundamental physical quantities. That means, suppose if we are taking the length itself here, distance itself here, the distance, dimensional formula is, distance is nothing but the length. Length already we denoted with the letter L. So L power of 1 is the dimensional formula of the length or distance. So to appear it as a beautiful equation, we include m power of 0, L power of 1, T power of 0 in the brackets. That gives the dimensional formula. Here see, it is an equation in terms of m, which is the fundamental physical quantity, L, which is the fundamental physical quantity, and T, which is also the fundamental physical quantity. Now here, observe here, m power of 0, will it be 0 or 1? It is 1 only. Okay. So m power of 0, likewise a power of 0 is equals to 1, as in mathematics. So here also we are applying the same. So here m power of 0 is 1, L power of 1 is L, and T power of 0 is 1 only. Then you will finally get the equation, same equation. Right, got it? This is the distance. The distance equation we can get from the fundamental physical quantity only. Next one is displacement. Displacement. The shortest distance between the 2 points is called as the displacement. What does that mean? Suppose A point and B point, 2 points are there. There I drawn the shortest, that means a straightforward line between the 2 points A and B. Another path also there, like this. This is path 1 and path 2 and path 3. Among all these three, the straight path or the shortest one is path 2. This path 2 is called as the displacement. So the shortest distance between 2 points is called displacement, which is denoted with the letter S. Denoted with the letter S. Okay. Next, whether it is vector quantity or scalar quantity. From the figure you can observe. Scalar means it should have the magnitude. Vector means along with the magnitude it is also having the direction. So whether this path 2 is having direction or not, as we already discussed earlier, it is having a straight path from A to B, a particular direction. That's why it is a vector quantity. So it is vector quantity. Next, what about the units? The displacement can be measured in terms of meter, because it is also length, it is also distance. Shortest distance we are talking about that. Okay. Next is CGS unit, centimeter. CGS unit is centimeter. Next, will it be positive or negative or 0? Will it be positive or negative or 0? Yes, it can be positive or negative or 0 also. Let us discuss with examples. This was given in a NEET exam also. When it will be positive, when it will be negative, when it will be 0. Let us see here. The distance or displacement can be either positive or negative or 0. Let us see. For example, if you consider the distance between the two walls, this is wall 1 and this is wall 2. Between these two walls, certain gap is there, or that means a distance is there from here to here. Let it be, let D is equals to 30 meter. I am taking 30 meter. Now, if you are moving from wall 1 to wall 2 in a straight line, from wall 1 to wall 2 in a straight line, then it can be displacement. Got it? If you are moving in a straight line, it can be displacement. If you are moving zigzag, that means zigzag path if you are following, that will be distance. So here I am considering the displacement only. Whenever you are moving from W1 to W2, that displacement can be taken as positive. Again, if you are moving from W2 to W1, that will be negative. That will be negative. When will be 0? See here, you got the positive value, you got the negative value also. What about the 0 value? If you find the total displacement means upward motion as well as the downward motion. Okay, to and fro motion. If you are considering here, then the total value will be plus 30 minus 30. Upon adding, you will get it is 0. So here positive displacement, this is, and this is negative displacement, and this is 0 displacement. So I think you would understand about the positive and negative, and as well as 0 displacement of the, 0 values of the displacement physical quantity. Okay, right? And the dimensional formula, what about the dimensional formula here? df. Since it is also distance, okay, shortest distance. So since it is the shortest distance, then it can be equivalent to length. Length is denoted with the letter L. So that's why its dimensional formula will be L. So this can be written as m power 0, L power of 0, L power of 1, T power of 0. This is the dimensional formula of the displacement. Okay, got it. Next is suppose I am considering the one circular path like this. This is the circular path having the radius r. Okay. Now, if a person at the point A, if a person is starting and moving along the circumference of the circle like this and reached to opposite point, quite opposite point B, along the path A, C, B, and here B, D, A. Okay. Here the direction of the motion of the particle or the person, whatever it may be, you are thinking. Suppose you are in that place only. Whenever you are following the path A, C, B, and this B point is quite opposite to A, then AB gives us the diameter of the circle, isn't it wrong? AB gives us the diameter of the circle. Here AB also gives us the shortest distance between the 2 points. Okay. Here what is the distance, what is the displacement? We need to calculate. Suppose here this is the R is the radius. Now in this case distance from A to B in order to reach from point A to point B via C, through C, that is giving the distance. Now distance is equals to what it will be? See, along this path only the particle will cover. Along this path only the particle will cover. That is the distance. Displacement means between these 2 points, what is the shortest one? That only we have to consider. Whether you are following in this direction, that means you know there is no need to move along this path. A నుంచి B కి స్ట్రైట్గా ఇలా మూవ్ అవ్వాల్సిన పని లేదు డిస్ప్లేస్మెంట్ కేసులో. డిస్ప్లేస్మెంట్ అనగానే ఏంటంటే రెండు పాయింట్స్ మధ్య ఉన్నటువంటి షార్టెస్ట్ డిస్టెన్స్ని మనం ఇలా తీసుకోవడమే. సో here distance is equals to, this is called as the semicircle. What is the circumference of the semicircle? Full circle is 2 pi r. So semicircle is pi r only. So pi r. That means suppose if the distance is taking as S A C B is equals to pi r. Whereas displacement is equals to, that means from A to B, displacement is equals to what it will be? From here to here. Here to here this is R, and here to here this is R. Totally 2R, which is equivalent to the diameter of the circle. So that is equals to R plus R, that is equals to 2R. There asked one question, what is the ratio of the distance and the displacement? covered by a particle in the semicircle which is having the radius r. Then how to calculate that? I already gave you the hint here. The distance SACB is equals to pi r, displacement is equals to 2r. Suppose if the displacement is taking as SAB, then SACB by SAB is equals to pi r by 2r. So r cancel, you will get it value as pi by 2. Pi is nothing but 3.14. Okay. Next, suppose ratio is reversed. That means SAB divided by SACB is equals to 2r by pi r. So r cancel, that is equals to 2 by pi. That gives us the ratio of the displacement to the distance in case of the semicircle, right? Suppose same circle I am taking. Same circle. Instead of reaching to the point B, they reached to the point A. They reached to the point A. Then what will be the distance and the displacement? Now, distance when reached from A to A. That means you will start at the point A and following the circumference of the circle in the path A, C, B, D to A. Then that gives us the S, A, C, B, D, A. What is its value? That is simply equivalent to the circumference of the circle. So circumference of the circle is 2 pi r. So this is the distance. Now displacement from A to A. Here, whenever you are starting from here and following the path A, C, B, here opposite point, at this opposite point we already calculated the displacement, that is 2r. That means from here to here in this anti-clockwise direction. See, this is called as the anti-clockwise direction. So, and the particle is starting from here. The displacement in this direction can be taken as positive, and whenever it goes from B, D, A in this path, the displacement can be taken as the negative. Okay, that means here this is plus 2r, then this will be minus 2r. Upon adding these two, minus 2r plus 2r gives us the 0. So from this example we can simply identify that the displacement of a particle whenever it reaches to the same point where it started. That means whenever it starts from certain origin or whenever it starts from a certain point, after completion of the motion, if it reaches to the same point, then the displacement will be 0. No need to calculate. For example, another example is, suppose if you are taking the one square having the side A. If a person is starting from the point P here, one corner of the square, along the path if he moves and finally reach to the point P, then what it will be? The distance will be distance is equals to, see, along this path he followed. This is A, this is A, this is A, this is A. Perimeter of the square, that gives us the 4A. What about the displacement? What about the displacement? So if you observe the arrow marks here, in this path if it is taking as positive, opposite to this one as negative. Next, in this path if you are taking as positive, opposite can be taken as negative. So all are having the same values. One is positive, negative, positive, negative. Upon adding all this, then what you will get? Plus a, minus a, plus a, minus a. Finally value is 0. Is it clear? Got it? Okay. Instead of that, sometimes some other points if you are considering. Square I am taking here. Each side is a. Let this point A, B, C, D. Okay. Now, distance between A and C. A and C. Distance is asked there. Then what you can, how can you calculate? Let it S, A, B, C. That will be followed from A to B as well as B to C. So from A to C, that distance can be covered by means of the paths A to B as well as B to C. So if you are taking that one as S, A, B, C, then this will be given by A plus A plus A plus A only. A plus A, that is equals to 2A. What is the displacement? In this case, what is displacement? Tell me. The shortest distance between the 2 points, that is called as the displacement. How to get the shortest distance? Then you have to add the A point as well as C point. A point as well as C point. This gives us the displacement. So, displacement SAC is equals to, how to calculate that? You know this side as well as this side, and it seems to be a right angle triangle. So, for right angle triangle, Pythagoras principle is what? Hypotenuse square is equals to opposite side square plus adjacent side square. So according to that principle, how you will get this one? Square root of AB square plus BC square. Opposite side is AB. So AB square plus this one is BC square. That is equals to square root of A square plus A square, which gives us square root of 2A square, that is equals to root 2A. That is equals to root 2A. Now if you are calculating the ratio between the distance and the displacement, what you will get? Distance SABC divided by SAC is equals to 2A divided by root 2A. So A cancelled, 2 by root 2 will be. So this is equals to, this root 2 will be cancelled by root 2 times in 2. So finally you are having the root 2. Okay, got it? Similarly, in case of a rectangle also, that same type of calculation will be. Okay, got it. Next is speed. What is meant by the speed? The rate of change of distance is called as the speed. The rate of distance is called speed. So here definition. Rate of, the word rate of means that physical quantity should be divided with the time. If any physical quantity is dividing with the time, means that automatically we can call it as rate of. Okay, got it? So here, whether the speed is physical scalar quantity or vector quantity. So in the definition itself, the rate of distance we are saying, distance is a scalar quantity. What about the time? Is it a scalar quantity or vector quantity? If anybody asks you about the time, what will you say? It might be 12 a.m. or 9 a.m. or 3 p.m., whatever it may be. But not like in the, suppose 9 p.m. in the direction of east. We shouldn't say like that. Isn't it or not? So, the time is not a vector quantity. We cannot say, we cannot express the direction of the time. It is having magnitude only. That's why here the distance as well as the time are having the magnitudes only, no directions. That's why speed is a scalar quantity. Next, what about the units? What about the formula? Here speed can be represented with the letter V, and V is equals to, according to definition, distance by time. So S by T, distance by time. Basing on this formula, we can express the units also, SI units as well as the CGS units. Now CGS units. See here, the distance can be measured in terms of centimeter, whereas the time can be measured in terms of second. So that's why centimeter per second is the CGS unit of the speed, and SI unit meter per second. Next, what is the dimensional formula of this one? Here, according to this formula, S by T, S is nothing but distance and T is nothing but time. So distance also can be equivalent to length. Length dimensional formula is L, and time dimensional formula is T, L by T. This can be represented with L T power of minus 1. This also can be written as M power of 0, L power of 1, T power of minus 1. So this is the dimensional formula of the speed. Okay, right? So again in the next class we can continue.